Hello, ndikulandireni tsiku lero pamene tikufuna tipitirize ndi phunziro lathu la trigonometry. Lero tili mu lesson number 2. Today we are going to look at the trigonometric ratios of some special angles. So there are some special angles which we need to find their ratios, trigonometric ratios, without using a calculator. So let's look at those special triangles. We have 30 degrees, 45 degrees, 60 degrees, 0 degrees, and 90 degrees. So our main objective today is to find the value of those trigonometric ratios. Remember, last time, timagwisa ntchito calculator. But with these special angles, tikonza kupeza ma trigonometric ratios ake without using a calculator. Expected background knowledge zimene mukuyenera kudziwa before we go further into this lesson. Mukuyenera mudziwe Pythagoras theorem imene by reaching this far mukuyenera kukhala kuti mukuyidziwa. And mukuyenera kukumbukira zimene tinapanga ma trigonometric ratios imene ma formula amene tinagwisa ntchito acha kuti tipeze those trigonometric ratios. So those two things are very important for us to survive in this lesson. For example, we can have this right-angled triangle. Okay, you can say that's C, A, B. If it is Pythagoras, you know that it's a hypotenuse. AC squared should be equal to opposite and adjacent squared, sum them. So it's BA squared, BA plus CB squared. So that's Pythagoras theorem. You have to know that. And our ratios, you remember sine C. We use the SOHCAHTOA to memorize our formulas. SOHCAHTOA. Okay, so sine C, this one, O stands for opposite, H stands for hypotenuse. So opposite in this case, it's AB. Okay, side opposite to angle C, side opposite to angle C. That's our angle, right? AB. Hypotenuse is CA. Okay, that's sine and cos, the same stuff. We say cos C should be equal to adjacent over hypotenuse, and your adjacent is CB, which means CB over hypotenuse CA. And tan, you're going to do the same, tan C, and angle C will be equal to opposite over adjacent, and opposite is AB over adjacent is, CA. CA. Okay, so those are two areas you have to know as we are going through this lesson. Now let us look at the trigonometric ratios for an angle of 45 degrees. All right. Yeah, let's consider this figure here. We have axis Y and axis X. Okay, so this is more or less like the floor. This is the height. This is along the ground, x-axis. This is as you go up. So you can be anywhere else. This could be a wall, and this could be a ground. So that something like that. So there could be something like a ladder bouncing up. Now you might want to raise that ladder to an angle. In this case, we can raise it up to angle 45 degrees, and we can say that ladder we can label it as A. Okay. So along that ladder, you can stand at any point and drop a line perpendicular to OX. Okay? So the whole idea, remember, when we are doing trigonometric ratios, we are dealing with sides and, of course, angles. But today we are going to deal more with sides. We have to know the values of these sides for us to apply to apply those formulas of finding trigonometric ratios that we covered. So our main duty today is to find the lengths of these sides. After finding the lengths of those sides, we apply into those formulas to find the ratios. So we are also going to make some assumptions. So we need to be together on that one. Okay, so in this case, you can see that this is 90, that is 45 degrees. Okay, so if you try to apply angle sum of a triangle, let's consider triangle POM. Okay, in this triangle POM, you can see that angle POM, this angle POM plus angle PMO plus angle MPO, this angle. All of them, their sum should give you 180 degrees, angle sum of triangles. So this one we know, and this one we know is 90 degrees. It's a right angle triangle. POM is 45 degrees plus PMO, that's 90 degrees, plus angle MPO should be equal to 180 degrees. All right. So if you add 45 plus 90 degrees, I think this is should be 135 degrees plus angle MPO. The whole of that should be equal to 180 degrees. All right. And which means angle MPO should be equal to, we are going to 180 minus 135 should be 45 degrees. Which means this angle as well here is 45 degrees. Now, if you look at the 45 degrees that side, 45 degrees that side, it means we have an isosceles triangle. An isosceles triangle, properties of an isosceles triangle, base angles of an isosceles triangle, and okay, so if we have these base angles equal, it means this line and that line ndio fananazo. Okay, it means OM, therefore we can say that OM should be equal to PM. Okay, based on isosceles triangle, isosceles triangle. Okay, then since we are trying to find my sides, we already know this side ndio fanana. So we can let one of that side, let maybe let's say PM to be equal to A. Okay, it means it will be equal to OM. So there is A, there is A. So we are remaining with OP. Now finding OP, we can use Pythagoras theorem. So using Pythagoras theorem, we can say that OP squared will be equal to OM squared plus PM squared. So we can as well say OP squared should be equal to OM squared plus PM squared. All right. So OP we don't know. OP squared will be equal to OM is OM. Remember we say it's A, so we can substitute A squared plus PM. We can also put our A there. PM we also find it to be A. So we can say that this is equal to, these are like terms, we can as well say 2A squared. Okay, so we take square root of both sides. Yeah, it will be O, okay, square root OP should be equal to square root 2A squared. But that one should be equal to, can be simplified as root 2 times root A squared. Right, so reaching that far, we can as well say, because of space, let's go to this side. We can say that we can say that, and remember, square wheel and that root can cancel, so it will be OP will be equal to root 2, okay, this one, root 2, that one, times root a squared. So that square can go, so it means you remain with a that side, so times a. So it means OP should be equal to root 2 times a. Alright, which means OP times also is root 2 times a. Alright, so all the sides tabeza, we can now happily go and substitute into our equations these values in meter spaces. Okay, so we can put our triangle here. We can put our triangle here to say that's our right angle triangle. Okay, that is O, that's M, that's P. Remember OP, we found that is root 2A, that's A, that's A. Okay, so if we are to use SOHCAHTOA, remember we are using SOHCAHTOA just to remember the formulas of finding trigonometric ratios. Okay, so if we can say that, let's say from this one, remember this is, this angle is 45 degrees. 45 degrees. So if we can say sine 45 degrees, this one should be equal to opposite divided by hypotenuse. Opposite over hypotenuse. So sine 45 is equal to opposite over hypotenuse. So what is our opposite? In this case is PM over hypotenuse is OP, which will be equal to PM is A over OP. OP is root 2 times A. So A and A will go, you will remain with 1 over root 2. So sine 45 degrees is given as 1 over root 2 in that side form. And we can as well say that cos 45 degrees, that one will be equal to adjacent over hypotenuse. Which one is our adjacent? OM. Okay, OM. So it will be equal to OM adjacent over hypotenuse. Hypotenuse is OP. This one will be equal to, and OM is A, has the value of A, over OP. OP is root 2 times A, which will be equal to A and A will cancel. You remain with 1 over root 2. Okay, then let's look at tan. Tan 45 degrees. This one will be equal to opposite over adjacent. So opposite is PM over adjacent is OM. And this one, PM will be equal to A. OM is also equal to A. So A and A will go, remain with 1. So our trigonometric ratios for 45 are these ones. Sin 45 is 1 over root 2. Cos 45 is 1 over root 2. Tan 45 degrees is 1. Okay? These are the things that you have to know. You don't have to memorize them. You have to know them. Okay? It's easy to find them. Okay? Now let us look at trigonometric ratio which is 45 now. I mean for 30 degrees. Okay, the same thing. we did. We only need to find those sides. Okay, we try to know one side, then we find my side now in reference to that side. Okay, so the same thing will happen from the horizontal line or axis line. You raise something, whether it's a rod or anything else, to an angle of 30 degrees. And at any point from there, you drop a line. And make sure in this case, we are going to drop it beyond M to P. Okay? The whole idea is to make sure that we find what we need. Okay? So, if you drop that, make sure you drop it. PM should be equal to MP hash. Okay? This line should be equal. Alright? And by doing that, it means this angle will also be equal to 30. Alright? By doing that, that angle will also be equal to 30. And if you see, this is 90, this is 30, 90 plus 30, that's 120. If you consider triangle OPM, okay, that's the angle sum of a triangle. Let's just put it down. Consider triangle OPM. Okay, so if you add all the angles, you'll find out that we have angle, in this case angle OPM will be equal to, okay, 180 degrees minus, in bracket, 30 plus 90 degrees. Okay, so this will give you 180 degrees minus, that's 120 degrees, which is equal to 60. Take a switch, means that angle is 60 degrees. The same applies. This side is 90 degrees. So 90 plus 30, that's 120, which means you'll find that angle 60 degrees. I'm not taking much time on that one. You must know already those ones. Okay, so if you look at it, you have here 60, there 60, commercial total, yeah, popo, it's a 60. In other words, we have an equilateral triangle here. We have an equilateral triangle here. Okay, we have an equilateral triangle here. So, let's do something else to see how we're going to do it. Okay, let's let PM to be equal to A. Okay, this side should be equal to A, which means we need to find the OM and the OP using A, but following what we have done here. Okay, following what we have done here. But remember, PM is the same as MP dash. Our construction, we constructed them in that to be that construction. Constructed them to be that. So it means that's A, which means P dash will be equal to 2A. Okay? PM plus MP. PP. Yeah, so PP, that one should be equal to 2A. Remember, we concluded that having this side as 60, this side as 60, that side as 60, it means this is an equilateral. Therefore, if it is an equilateral triangle, it means this side should be equal to OP, should be OP dash, and it should also be equal to OP, which means PP dash, this one should be equal to OP dash, should be equal to OP, should be equal to 2A, which means this side is equal to 2A. Alright, so we have that side, we have this side, we are remaining with OM. How do we find OM? Now we are going to use Pythagoras theorem. Using Pythagoras theorem, we know that OP squared should be equal to OM squared plus PM squared. OP squared should be equal to OM squared plus PM squared. So, in this case, this is what we want. We are going to put it here. OM squared should be equal to OP squared minus PM squared. And OP squared, we know that it's 2A, bracket squared, OP is 2A, and this one should be subtracted with. PM is A, so it will be A squared. So it means OM squared should be equal to, let's expand this one. How for? A squared minus A squared. This will be equal to 3A squared. These are like terms. Okay. And then OM, if we take square root both sides, it means OM will be equal to square root 3 times A squared. If we further simplify that, it will be root 3 times root A squared, which will be equal to root 3. Root A squared is the same as to say A. So it means root 3 times A is OM. Okay, so we can rewrite that triangle. We can rewrite it. Okay, we have O there, we have P here, we have M here. This is the right angle. This is A, this is 2A, and this one is root 3A. Okay, root 3A. Alright, let's proceed. Remember that triangle. Have A here. This is 2A. This is root 3A. That's all. Remember, this angle is 30 degrees. I think it's angle 30 degrees, yes. I don't know if angle 30 baja. 30 degrees. That's PM. So that's A. Alright. Remember, so katoa. Katoa. Yes, katoa. Let's take sine now. We know all the sides. So sine 30 degrees will be equal to opposite over hypotenuse. And in this case, our opposite is PM over hypotenuse is OP, which is equal to, what is our PM? We say PM is A. OP is 2A. A and A will go, you remain with half, 1 over 2. Okay, then let's see cos. Cos 30 degrees should be equal to, cos is adjacent over hypotenuse. Adjacent is OM over hypotenuse, which is OP, which is equal to OM is root 3 times A over hypotenuse, which is 2A. Okay, now A and A will go, you remain with root 3 over 2. So you have root 3 over 2 as a trigonometric ratio of cos 30. And let's see tan 30 degrees will be equal to opposite over adjacent. And our opposite is PM, our adjacent is OM. PM is A. OM is root 3 OM, that and that. Is root 3. Okay, that's A, which is equal to A and A will go. You remain with 1 over root 3. Okay, so that's the trigonometric ratio for, those are trigonometric ratios for special angle 30 degrees. Okay, now let's look at this trigonometric ratios for an angle of 60 degrees. The same things. You have OX as your ground, and you have Y as in your height. So you raise something, whether an radar or anything else, to an angle of 60 degrees. Then you choose any point, in this case P, drop a line to M, which should be perpendicular to OX. So you have a right angled triangle. Now for us to find that side, we also need to do some constructions. In this case, we extended OM to M dash. Okay? But this one should be equal to that one. Alright? Should be equal to this one. Then you drop that line. Okay? So there are two triangles there. Two triangles. Then these two triangles, remember, this one should also be perpendicular. Okay? But you see, this side and that side are equal. This side and this side is also equal. And this one and that one equal. 90 degrees. Which means that is a congruent. That is congruent. Okay? So, from these two triangles, we know that it has two sides, PM to be equal to PM. Okay? Reason common. Yeah, common size. Okay? But triangle POM and PMM. PMM dash. Okay? And this side A. I will also ndo fanana. This angle and that angle, 90 degrees ndo fanana. OM and MM zofanana. Therefore, we can as well conclude that PMO, that triangle, should be congruent to triangle PMM dash. Okay? Reason they're congruent. Reason simple. That angle equal, that side equal, and that side common. Okay? But we also know that angle P O M, okay, angle POM should be equal to angle PM dash M should be equal to 60 degrees. These are congruent triangles. Okay? Since this side and the other side is of fanana, side in the side in your fanana, angle in the angle in your fanana, which means angle in the angle, you're going to also fanana, 60 degrees. Okay? So we have this one as 60 degrees. Okay? So if this is 60 degrees, that is 90 degrees. This one is also 60 degrees. That one is also 60 degrees. It means if you do angle sum of a triangle, if you do this 90 plus 60, that's 150. 180 minus 150, it means you have 30 degrees here. The same will apply to that. 30 degrees. So you have one equilateral triangle as well, which means this side, that side, and this whole side is zofanana. I hope we are together. Then if we say that let OM from this triangle PM, okay, let OM from this triangle from, let's just put it down, from triangle POM to be equal to A. It means that OM dash will be equal to A. Remember, we said that one and that one are equal. If this is A, that is A. It means the whole distance OM dash is 2A. And we have also concluded that if this is 30 plus 30, that's 60, there 60, there 60, it's an equilateral triangle. So for an equilateral triangle, all sides are equal. It means that side is also 2A. So we have two sides now for triangle POM. We have A there, 2A there. We are remaining with that side. Okay, we are remaining with PM. We use a Pythagoras theorem as well to find PM. Okay, so we will consider triangle OPM, that is OPTM. So we have OP. Let's start from above. OP squared should be equal to OM squared, that's OM squared, plus PM squared. OM PM squared. Okay, and remember OP, in this case we want to find PM. So let's make subject of the formula PM squared will be equal to OP squared minus OM squared. Okay, so this will be equal to OP squared is that, let's put in bracket 2A squared minus OM is just A squared. So it means PM squared, okay, will be equal to this one here. If you expand that one, it will be 4A squared. So 4A squared minus A squared. These are like terms. 4A squared minus A squared will be equal to 3A squared. Okay? Therefore, if we take square root both sides, you will have PM will be equal to square root 3 times A squared. Alright, so this one will give us root 3 times root A squared. So that and that will go. Okay, let's take it to that side. You have, it means PM will be equal to root 3, and that will remain with A here, root 3 times A, which means PM is equal to root 3 times A. So if we are to draw our triangle and show its sides, this is P, this is M, that's 90, that's 60 degrees. It means this is 2A, this is A, remember that's all, and this one is root 3A. Okay, so basically that's that. So we are going to apply trigonometric ratios formulas to find our ratios. Okay, let's rewrite our triangle here. So that's A, 2A, I think this was root 3A. That was 60, that's O, P, M. Okay. Basically that's that. So still remember our SOHCAHTOA. SOHCAHTOA. Okay. In this case we are saying, let's start with sine. Sine 60 degrees should be equal to opposite over hypotenuse. In this case, our opposite is PM over hypotenuse is OP, which is equal to root 3 times A over OP is 2 times A. A will go, you remain with root 3 over 2. So that's our sine 60 root 3 over 2. And let's look at cos 60 degrees which is adjacent over hypotenuse. So our adjacent is OM over hypotenuse. Hypotenuse is OP. And OM is A over OP 2A. So that and that will remain with 1 over 2. Okay? So we have that. We have that. We have half now. Cos 60 degrees, trigonometric ratio is a half. Let's look at tan. Tan 60 degrees. Tan is TOA, opposite over adjacent. PM, that's our opposite, PM over adjacent, OM, which is equal to root 3 times A over A, which is equal to A and A will go, we remain with root 3, which means our trigonometric ratio at this level for sine 60, for 60 degrees, for sine we have root 3 over 2, for cos we have half, for tan we have root 3. Okay, so basically that's that. Then we are remaining with 2, 0 degrees and 90 degrees. For these ones, you just have to know them to say that sine 0 degrees, we are not going to prove these ones. Sine 0 degrees is equal to 0. Okay, cos 0 degrees is equal to 1. Tan 0 degrees is equal to 0. Sine 90 degrees is equal to 1. And cos 90 degrees is equal to 0. Okay, here's the summary of whatever we have done. Okay, you can try everything that is here. You'll see what it means. I hope that's all for what I had for you in this lesson. Go back, revisit the videos and understand them. Mukakhala ndi background iyo yokwanira zikhazo savuta kwambiri pamene mudzaonenso trigonometry part 2 ku buku la form 4. Ndikufuneni zabwino zonse sabatayi, tikumanenso sabata linkodza. Zikomo.